Hello, everyone. There is going to be a great deal of information coming up because we only have about 5 weeks left. So I will be putting up chapter 11, which is this one, and then I will put up and record the seed article we are going to use for our final paper, as well as um, I will put up by Monday how to do a results section and sort of the paperwork behind that one. The hope with that is that you can use um, eventually be able to use that results section as a template for your final paper. But we'll get to that discussion a little later. In this chapter, we skipped over chapter 12 to get to chapter 11 after, because I wanted you guys to be familiar with factorial designs, and then we could go back and talk about internal validity problems. In this chapter, we talk about two things, which was the quote unquote dirty dozen of confounding and obscuring variables, or the 12 ways that we could commit um, internal validity errors, things that could be interfering with our DV. And then the idea of null effects. So I will separate that into two different lectures. The null effects one should probably be faster than this one, but either way, let's go along for the ride. I'll read the chapter objectives, and then after this, I will record the second half of chapter 11. So we are going to review the 3 threats to internal validity that were talked about in chapter 10. We talked about confounds, which are, extraneous variables or things that could interfere with the relationship of the IV and the DV. We'll talk about selection effects, which we already talked about in chapter 10, which is not randomly assigning or using a match design, or order effects, which is our selection effect sort of idea with a within subjects design or within groups, and that is that they all see the same order first. So those are the 3 that we established in chapter 10. And this chapter, chapter 11, goes on to identify 9 more threats to internal validity, called history, maturation, regression, attrition, testing, instrumentation, observer bias, which we have gone over before, demand characteristics, which is the participants basically guessing what the answer is, and of course placebo effects, where people report increases even though they're not taking the actual experimental group or drug or something like that. So I'll explain those and how to identify them. And then I will explain how just adding a control group or comparison group will help to avoid a lot of these internal validity threats that were just mentioned, how double-blind studies can help, especially with observer bias and demand characteristics. And the way that we design our choices can also help research avoid a lot of these threats to internal validity. And of course, for order effects, as we've already established since pretty much week 4, 3, whatever it was, is doing, actually week 2, really, is doing a counterbalance. So, yeah. I will articulate reasons that a study also, this goes into the second half of the chapter, might result in null effects. Remember, null effects are when there is no difference between groups. Your p-value is greater than 0.05, so there's no significant difference. But we want to explore, as researchers, a little more about why you got a null effect. There are actually 3 different reasons why one may get a null effect. One is not enough variance between groups. One is too much variance within each group. Or you might actually just have a true null effect and you don't have any real difference between the groups. And that's just the way it is. But it's not just simply, oh, well, I guess it's just a true null effect. There may be other things that are underlying that. I will describe at least 2 ways a study might show inadequate variance between groups and indicate how researchers can identify these problems. I will also explain why large within-group variance can obscure the between-group differences. And finally, we'll talk about 3 causes of within-group variance: measurement error, individual differences, and situation noise. And I will talk about how each of those may be reduced. So, in this half, we're going to be talking about these dirty dozen threats to internal validity, asking the question, did the independent variable really cause the difference here? And then, for the second half, which I'll record right after, interrogating null effects. What if the independent variable actually doesn't make a difference? The levels of the independent variables or variable don't make a difference. There's no difference between groups. Is it really just that there's no difference? Stay tuned. So, threats to internal validity. When we talk about causal claims, again, this is the only type of claim of the 3 that deals with internal validity. And in this case, not only does it deal with internal validity, but internal validity becomes the main priority. What we're asking is, did the independent variable really cause the difference? So remember, in a causal claim, we're not just saying A is related to B. We're saying A causes B. But it goes even further than that. It goes as far as to say A, and only A, to the best of our ability, caused B. So, in this case, we're going to talk about a really bad experiment and why it is. This is normally where I'd ask you guys, but since I have to be the voice of reason because I've got nobody to answer me in an empty room, I will tell you. 6 potential internal validity threats in the really bad type of experiment, which we call the one-group pre-test post-test design. 3 more potential internal validity threats in any experiment. And since we have so many types of threats to internal validity, we attempt to answer the question, or at least I do, are experiments still useful? Spoiler alert, what's the point of this class, right? So yes. So here is what the book calls the really, really bad experiment, also known as a cautionary tale. This is called the one-group pre-test post-test design. Now remember in chapter 10, we talked about a post-test only type of design where you're only measuring the DV once at the very end. So that would be, the example would be the one that I've been giving in class since the first week, which is splitting you guys up into a group of studying versus not studying. Giving everybody the same lecture material or videos. The only difference is the half of you in the study group study about 6 hours a week, and the other half in the control group do not. Then I test you once, which is the exam. The pre-test post-test design, if you remember, is you have participants, you give them a pre-test measure. So maybe it's a way to see if we do something with anagrams and you just want to see if people are just capable of doing them, or if the groups are pretty equal in terms of their ability to do anagrams, right? Then you give them a treatment. So maybe one of them gets like a special mnemonic study guide, or, you know, a way to try to, you know, remember how to unscramble words better, or some sort of memory technique. And then you measure again. So this is a really bad experiment. If we look at an example of how this would work, we're going to use this during this chapter. So we have a bunch of campers, right? We have a bunch of kids that are campers, and so let's pretend that it's not a social distancing issue. And the campers are going to a sleepaway camp for a week. When they first get there, we measure how rambunctious their behavior is, bouncing off the walls and all of this stuff. The treatment that we give them is to reduce their sugar intake. And then at the end of a week of camp, or 5 days, we measure their behavior again. This is a really bad experiment. Why? I'll get to that in a second. Let's try another example before we try and figure out exactly why this is such a bad experiment. We have a group of depressed women. All of them are depressed. So, of course, as our pretest, we measure their depression. Sure enough, on average, they're all pretty moderate to severely depressed. Then we give them cognitive therapy, and then we measure their depression again after the therapy. Again, really bad experiment. Why is this? Well, this is where I'd give you guys the floor. However, I don't have that opportunity. So the answer is um, because there's nothing to compare them to, right? And there may be other problems associated with the way that we do this. So with participants, you're only putting them in one group. You're not assigning them into more than one group. So is there a selection effect here? I would tend to say yes. We are pre-test measuring, so at least we know that there's something to be studied there. We give them some sort of treatment, and then we measure again. The problem is that everybody gets the same treatment as well, right? So this is a really, really bad test. There may be a few things going on. So in B, with campers, I'm going to use this example throughout this lecture. How do campers, if any of you have kids or brothers and sisters or cousins, nephews, nieces, when they get to camp the first day, don't you think they're going to be a little excited? So what's the problem? One of the problems with measuring their rambunctious behavior when they first get there. One, it's probably going to be really high. So this is this idea that we call regression to the mean, that they may be extremely high at first. So then we give them a task. We reduce their sugar. Well, the problem is their rambunctious behavior may not have anything to do with the amount of sugar. It's just that, man, this kid was bottled up, and now you let them loose onto this new camp with all this new cool stuff. They're going to be real excited and rambunctious the first day. So we reduce their sugar, and then we measure their rambunctious behavior at the end of the week. Well, there's something called maturation, which we're going to talk about, where the participants or subjects just sort of naturally get used to their surroundings. So although your kid may still be excited on day 5 or day 7 to be in camp, they're not going to be as excited as they were on day 1. So we also don't know, without a comparison group, whether it was the reduction of sugar, because you reduced it for everybody, did that actually cause their rambunctious behavior to go to decrease, or was it just simply because they had been there for a week already and they were not nearly as excited as on day 1? We don't know because it's a really bad experiment. Looking at depressed women, that's another problem, is that the women who were either selected for this or volunteered, self-selected maybe, they might be considered extreme. So you measure their depression, yep, they're really extreme. Then you give them cognitive therapy. But again, there's no comparison group that doesn't get cognitive therapy or that gets something else, like maybe an antidepressant. The other thing is, do we know if they even controlled for that? So you give them cognitive therapy, you measure depression again. What we're hoping to see as researchers is that their depression levels were reduced after cognitive therapy, but we have nothing to compare it to. And did we control for the fact that maybe they had family members talking to them in addition to the cognitive therapy, or that they maybe took antidepressants or things like that? We can't tell, or we can't know for sure that it was the cognitive therapy that reduced their depression, if anything. So again, this idea of the one group pre-test, post-test design is really problematic, especially if you don't have anything to compare it to. So if we were to graph the really bad experiment, remember what I said from chapter 10, that if we only have 2 levels of one IV, it's probably not a great idea for a line graph. This is where a factorial design thrives with a line graph. But for 2 groups to be compared to each other, again, it's much better visually and for interpretation reasons to see it in a bar graph. So graphing it, you don't want to use a line graph in the first place. So I'm just giving you bad advice left and right at the beginning of this chapter. Looking at their rambunctious score behavior, again, at the beginning of the week, we do see it higher. At the end of the week, after a sugar-free or reduced sugar diet, we see that it has decreased. From this graph, everything looks great, right? Hey, look at B, depression score. Before therapy, they're pretty depressed, on an average of 18 on a depression scale. Post-therapy, they're down to a 10. Looks like they've, over 50% reduction in their score. Great. Compared to what? All we're looking at is the beginning of the week versus the end of the week and pre and post therapy. Nothing to compare it to, right? Did the sugar-free diet actually decrease their score, or were they just less rambunctious overall? Did the therapy actually reduce their depression score, or could there have been something else that did it? We don't know because we have nothing to compare it to. So we talked about our original 3 types of internal validity problems: confounds, something other than A causing B. We talked about selection effects for a between groups or independent groups design, not randomly assigning, so that there may be some sort of unsystematic variance where one group was already better equipped, maybe less rambunctious, less depressed than the other group, if we were to do 2 groups. And of course, in a the pretest post-test is kind of like a within subjects, right? Kind of. Don't get confused. But in a within subjects design, did we counterbalance, right? So that would be order effects. So we had confounds, selection effects, and order effects. Those were the ones we've already established from chapter 10. Now in chapter 11, we have 6 more internal validity threats in this specific type of the one group pretest post-test designs, and it can carry over into more than one level. So the first one is called maturation threats to internal validity, where simply the behavior of the subject or participant changes. Maybe they just get a little more used to their surroundings, like the children's example. Maybe they grow bored from some sort of maturation effect. So we need to make sure we control for these things or look for them. History threats to internal validity. History happens to be or deal with any sort of outside co-occurring event that may happen at the same time. So, if we were to go back to the rambunctious kids, history might be that it's you're at a summer camp, so maybe it's really, really hot outside, and so they're really, really excited on day 1 to be there, and they're really, really great. And then at the same time, yeah, maybe you reduce their sugar, or maybe they get used to their surroundings, but also it just may be so hot, and there's not really good air conditioning up in the up at this camp, that they are just lethargic and tired because they're just right. So they're not so rambunctious, not because of being there, not because of a low sugar diet, but maybe it's just so hot outside and that just happens to mess with their energy levels and make them less rambunctious. Regression threats to internal validity. This is what I was sort of leading to for rambunctious behavior, or especially with the depression example. Regression to the mean means that sometimes we have unusually high or low scores at the beginning, and the next time that you take the test or the next time that you're tested, your score may be going back to a more regular average of what you get. So if I go back to the example of studying and not studying, there may be people in the studying group, there may be people in the non-studying group that do really well on the first exam. And it could be that they've taken Psych 92 before, and at least through the first exam, and then they dropped it for whatever reason. Maybe they had a full-time work commitment or something like that. But they had an unusually high score the first time because it's a test they'd done before, which actually will bring us back to number 5 in a second. Or in these women that signed up for the depression study, they were really depressed and they're like, ooh, free cognitive therapy. Or I guess it's just people, it's not women, sorry. Men and women so they were really extremely high on the depression scale. And whether or not the cognitive therapy itself did anything, maybe the next time they were tested, there wasn't an extreme reason. Like maybe some of these people were tested for depression after a pet or a longtime partner or somebody in their family had passed away, right? So their depression levels were just off the charts. And then after the therapy, maybe they were just less depressed because, at least they were over that one little incident that cause their depression score to spike? We don't know. Attrition threats are when basically people leave the study. So when we're looking at studies with drugs, maybe we can use an example of using a patch or some sort of like quit smoking therapy, whether it's a cognitive therapy or an actual drug, nicotine patch type of thing. Maybe they go through that, and then you want to do a follow-up like 6 months later or a year later. Chances are that some of them are just going to go back to smoking, and some of them were just like, you didn't pay me enough for this, so I'm not going to be part of the follow-up of this study. Or they failed, and they feel embarrassed about it because they went back to smoking, because it is highly addictive, right? So when they drop out of a study for whatever reason, we call this attrition. And you have to worry about, did you include them in the before score and the after score? If they're not there for the after score, you should not include them in the before score, right? Kind of like fishing for those outliers that we talked about in chapter 8. Number 5 is testing threats to internal validity. And this is, we kind of did examples of this in some of the previous assignments, where just being exposed to the same material can cause their scores to either increase or decrease. So a testing threat, if you give them an exam, if you do a pre-test, post-test, and you give them anagrams, and the anagrams are kind of similar, did they get better because of training, or did they get better because they recognized the anagrams and just knew to get them right? So that would be a testing threat. There is also a fatigue effect, where if you're doing a race or something like that, and you do a couple of pre and post tests, that later on your scores get worse, and that could just be because you're tired out from doing all of these things over and over again. So testing works in both ways. It can increase the data falsely, or it can also decrease the data falsely. Finally, we have instrumentation threats, which are threats due to the instruments that you use being unreliable, that you're measuring. Think back to the inter-rater reliability type stuff, where we talked about having to remeasure somebody's head circumference and things like that. You can always go back to that in the slides to refresh your memory if you want to. But instrumentation threats are, we're getting the wrong numbers because our measurements were wrong. Our instruments weren't calibrated, or we didn't do something correct, and that caused what we thought was an improvement, but really wasn't. So these are the 6 potential internal validity threats in that post-test, one group, pre-test, post-test, really bad experiment design. Or we could have combined threats. Like I talked about, it could be maturation and it could be regression to the mean, right? Especially for those rambunctious campers. So we could have more than one of these in that setting. So the question is, how do we mitigate these? And should we go over the definitions of these things? And the answer is, let's worry about mitigating after we go over the definitions of these things. So again, the internal validity threats that we went over in chapter 10, design confound, or what we call extraneous variables. The definition is some sort of second variable that unintentionally varies systematically with the independent variable. So in this case, what we call a confound, right, is if I say that A and only A causes B, this would be anything C, D, E, F, or G that could also cause a change in the score in B, not just A. So an example from chapter 10, if you let me refresh your memory before the exam, if pasta is served in a large bowl, and that pasta in the large bowl appeared more appetizing than pasta in a medium bowl, that would be a problem, right? We want to know that people took more pasta and ate more pasta simply because the bowl was larger, not because it was tastier or warmer or had meatballs or veggies in it, right? The meatballs would be an increase for me. The veggies would be a turnoff. So, but that may be different for some of you. Question to ask for this: did the researchers turn nuisance variables into control variables? For example, keeping the pasta recipe constant, the temperature constant, right? So when we hold these things constant, that sort of eliminates this idea of confounds, as many things as we can. We can't always know everything to hold constant, but to the best of our ability, at least. Selection effects. In a between group or independent groups design, when the two independent variables have systematically different kinds of participants in them. Let's say that we go back to the studying and not studying example, and I chose everybody on the right side of the room, or my right, your left, when we were in class, if you can remember back that far. And I selected the people on the right, on my right, just to be in the group that studies. Well, maybe that group was already better at studying. They were in class earlier, more prepared. And the ones on my left that kind of came in late and weren't really prepared and, not necessarily paying attention, they were in one group. Well, the problem with the selection that way is that the group on my right, the ones who were prepared, may already be better at taking tests than the people on the left. So from chapter 10, when we talked about the autism study, some parents insisted they wanted their children to be in the intensive treatment group rather than in the regular control group because they wanted more out of it. And if they were in that intensive treatment group, not only would they be getting intensive treatment, but there also may be a inherent difference in the way their families also treated them at home, more than just the intensive treatment. So we asked the question, did we randomly assign? Did the researchers use random assignment, or maybe according to severity of deficit in the autism spectrum, match groups? The ones that were more affected, we split them up. The ones that were medium sort of affected on the spectrum, impaired, split them up. The ones that were not quite as impaired but still on the spectrum, split them up, right? So we can use random assignment, or we can use match groups to equalize the groups and try to make them as even as possible before the treatment. For order effects, that's the within group design, and that is when the effects of the independent variable is confounded with carryover from one level or the other, practice, fatigue, or boredom. So remember from chapter 10, all participants in a bonding study play with their own toddler, and then they played with a different toddler. This would be what we call a carryover effect, because if you increase your oxytocin levels that high by playing with your own kid first, we don't know that enough time has passed that your levels would not still be high from playing with your own kid as opposed to a different toddler. But if they counterbalance the orders so that half of them played with their own child first and half of them played with a stranger's child first, then maybe we can control for that potential order effect. So these are the ones you guys were already familiar with, I hope. Now let's look at the other 6, and then 3 more to add to that at the end. Maturation, the definition is an experimental group improves over time only because of natural development or some sort of spontaneous improvement. The example to give, again, rambunctious boys settle down as they just get used to their camp setting. So, to address this issue in the really bad experiment, add a control group, right? So questions asked, did the researchers use a comparison group of boys who had an equal amount of time to mature, but did not receive the treatment, aka the low sugar or no sugar diet? History threats. An experimental group changes over time because of some external factor or event that affects members of a group. So there was an example in the chapter of a study done on dorm residents, so college kids, looking at whether they reduce their energy output if there is a go green type of initiative put in place. But the problem is, in this example, the study was run between September and November. Well, so it could be, in this case, that the dorm residents were trying to be green and responsible and trying to save money as well as energy. And it could have worked, but there is something else that happens between September and November. Oh, what is it? Oh, that's right, changing of the seasons. So the weather is getting cooler. So did they really use less air conditioning because they were trying to be better for the environment or save money on their power bill? Or is it just simply because the weather got cooler and there really wasn't as much of a need for air conditioning? So the question to ask for this history effect, remember this is some sort of external factor. This could also be applied to the boys at summer camp and that it was extremely hot outside during the summer. So maybe they just weren't as rambunctious because they were just really tired and worn out from the warm weather. So did the researchers include a comparison group? Again, that's a good way to avoid this effect, that had an equal exposure to the external event, meaning the cooler weather, but did not receive a treatment. They did not get the Go Green initiative flyer, so to speak. Regression to the mean. An experimental group whose average is extremely low or extremely high at pretest may get better or worse over time simply because whatever random events that caused extreme scores did not recur the same way after. So again, if you're looking at a group, the average for this group of depressed people is extremely depressed at the pretest. And that could be because some of the people volunteered when they were at their most depressed. And they volunteered for therapy when they were feeling much more depressed than usual. Maybe they feel that their normal depression is easy to handle, but when it became a little too much, they're like, oh, it's time to sign up for this study. So again, was it that the cognitive therapy worked, or was it simply that they were just not quite as depressed, right? Did the researchers include a comparison group? And again, another way to mitigate this, to try to help with this, is to add a control group so that we can compare and make sure that the difference was due to the actual treatment and not just to something else like regression to the mean. Did the researchers include a comparison group that was equally extreme at pretest but didn't receive the therapy? That way we can eliminate that threat to the best of our ability. The other three: attrition, testing, and instrumentation. So for attrition, an experimental group changes over time, but only because the most extreme cases have systematically dropped out, and their scores are not included in the post-test. The example: because the most rambunctious boy in the cabin leaves camp early. He was so rambunctious that they sent him home. He was just not behaving, going against the rules, and just being a bull in a china shop, if you've ever heard that expression. So because the most rambunctious boy in the cabin leaves camp early, his disruptive behavior affects the pretest, but not the post-test. He's the most extreme and the most rambunctious, but you're not going to get his score at the end because he didn't make it the whole time. If we did that and included his score in the pretest, but not in the post-test, it gives us sort of a wrong way of looking at this. So we asked the question, did the researchers compute the pretest and post-test scores with only the final sample included, removing any dropouts data from the pretest? Because he was so extreme, it will affect the pretest score, but because he wasn't there for after, that makes it appear that there may have been an improvement when really you're just counting a person who didn't get the post-test. So if Mr. Rambunctious is not included in the post-test, we simply would eliminate his data from the pretest and recalculate. So did the researchers compute the pretest and post-test with only final sample included, removing any dropouts data from the pretest group average? Testing effect, again, is a sort of type of order effect. An experimental group may change over time because repeated testing has affected the participants in a way that make the scores increase, like practice effects, carryover effects, or in a way that may make the scores decrease, like fatigue effects, getting tired and taking longer and longer to do something on subsequent attempts. So, looking at this example, a classroom's math scores improve because the students take the same version of the test both times, and therefore they're more practiced at the post-test, even if they didn't have specific instruction on it. So we asked the question, did researchers have a comparison group that took the same two tests? Did they use a post-test only design, or did they use potentially alternative forms of the measure for pretest and post-test? So I gave you guys the example also of anagrams, right? And so in this case, we could do anagrams as long as they're not the same ones. So is there an alternative version? Would you give students a test with anagrams, however, maybe the same number of letters to unscramble, but not exactly the same words? That would be a good way to do that. And also, of course, control group, right? Comparison groups. The last one is instrumentation for these 6. An experimental group changes over time, but only because repeated measurements have changed the quality of the measurement instrument. So if you have people coding how many times somebody smiles, or how much somebody is aggressive, and the more and more they do this, maybe the more bored they get, or they're being a little more lenient, or not paying as much attention. So is the same exact behavior coded as less rambunctious later than earlier, right? And that may have to do with the person coding. That may have to do with the participant maybe figuring things out. We're going to talk about a few of those things after, but instrumentation may be the person or the instrument that you're using to measure needs to be recalibrated or reinterested. So did the researchers train coders to use the exact same standards when coding throughout the experiment? And are the pretest and post-test measures demonstrably equivalent? Are they rating the same thing, using the same instrumentation? There may be a problem if the readout is wrong, whether it's due to human or machine error. Then we have the other 3, which we've also talked about in other chapters, like I think chapter 8. We talked about, or maybe it was chapter 7. Observer bias, demand characteristics, and the placebo effect. This rounds out the last 3 of the dirty dozen. In observer bias, we talk about an experimental group's ratings differ from comparison groups, but only because the researcher expects the group's ratings to differ. So the example here for the kids, the campers, and the rambunctious behavior is the researcher expects a low sugar diet to decrease their unruly behavior. So he really notices their calm behavior and kind of ignores any other wild behavior. This could be an instrumentation problem because the person who's rating them maybe isn't fully engaged or is biased in his or her measurements. So that could be observer bias. That could also be an instrumentation thing, right? Especially if your instrument is a person coding. So a question to ask: were the observers of the DV, which would be a rambunctiousness, unaware of which condition the participants were in? In this case, a comparison group does not automatically get rid of the problem because observer bias is, they're just gonna, be biased whether they realize it or not. So the other example from previous chapters was the maze bright rats versus the maze dull rats. And when research assistants were told their rats were smarter or dumber, the scores kind of match that expectation, right? So in this case, one of the ways to mitigate this is use a research assistant that doesn't have a specific bias. Demand characteristics. If you have a specific bias, you may not notice that, but the participants might. So in this case, the participants can guess what the study's purpose is and change their behavior in that expected direction. One of the problems when we talk about a within subjects design, especially, I know this isn't going into factorial, but if we think about it this way, a factorial design with 4 groups and you're having everybody do every group, there's a good chance that by the 3rd or 4th condition, they've figured out what it is that they're supposed to be doing, and that may change their answers, right? So we'll talk about that. But in this case, whether it's one group or whether it's multiple groups, the participants can guess what the study's purpose is, right? If in class, I talked about an example of giving a pill versus a placebo for an antidepressant maybe study, and the observer bias also turns into demand characteristic, right? So if I know who's getting which version of the pill, the placebo or not, it could be the way that I give it out. So I could say, for those that are getting the placebo, I'd be like, here's your meds. And for those that are getting the actual drug, I can say, here you go, here's your medication. And so just my tone of voice and enthusiasm could have the participants figure out which one was the placebo and which one was the real drug. In this case, campers guess that the low sugar diet is supposed to make them more calm, so they change their behavior and become more calm. They want to do what's expected, right? Or people claim that they're less depressed when they know they're taking the actual antidepressant as opposed to the placebo. So were the participants kept unaware of the purpose of the study Was it a between groups design, which makes participants less able to guess the study's purpose? Remember that in a within group or within subjects design, multiple groups may make it easier for them to guess what they're supposed to do. And instead of answering truthfully, they may try to answer more towards what they think the researchers want to hear, right? And then, of course, we also involved in that is the placebo effect. So participants in an experimental group improve only because they believe in the efficacy of the therapy or drug that they are receiving, not that it's actually doing anything. So in this case, for the women who were very depressed, women receiving cognitive therapy improves simply because they think that any type of therapy will work for them. Rather than it just being effective. So for the placebo, of course, you want to add a comparison group that received some sort of inert drug or placebo therapy. In this case, it could have been a cognitive therapy versus just sort of talking with somebody, because it could be that human contact and talking that could have improved them. If we add a comparison group that didn't get a specific cognitive therapy, then we can see whether or not a placebo effect would have happened, right? So that's your dirty dozen. Looking back, just in case, we have design confounds or extraneous variables, and we use controls for that. Control for things like pasta recipe, for the studying example, getting enough sleep, eating the same lunch, no caffeine for anybody, blah, blah, blah. Selection effects, again, for a between groups design, did we randomly assign or match design? Order effects is for a within subjects group or within groups design. Did we counterbalance so that half saw N first and half saw I first, or half played with their own child first and half played with a stranger's child first? Maturation, did the boys settle down simply because they got used to their surroundings, or was it actually the manipulation? History, did people actually have an effect that the Go Green campaign worked, or was it simply because the weather outside was cooler? Regression, did these people get less depressed because of therapy, or simply because they were extremely depressed at the start and this was just more towards their regular level of depression? Attrition, did we eliminate the scores, right? Did we see a difference in scores simply because the most rambunctious or the people that went back to smoking didn't come back for the post-test? If they did not, did we eliminate their data from the pretest? Testing effect, did these people do better or worse because they simply saw the test before and after? Was there not an alternate version of the test? Did they get better at math problems simply because it's the same math test that they were given? Or did they get worse at something that was being timed simply because they were tired? Instrumentation, again, is a group changing because repeated measurements have changed the quality. So whether it's a coder who gets bored or gets a little more lenient at the end, or whether it's an instrument that was not recalibrated enough from the beginning to the end. A lot of these, then we have the last three. We have observer bias, where the observer or the researcher or research assistant accidentally gives away something and is biased towards the way that they count something, which could also be an instrumentation problem. With observer bias and demand characteristics, where the participants guess what's going on, especially in a within subjects design, we usually eliminate those with a double-blind study so that the research assistant has no idea who's in the placebo group and who's in the antidepressant group. And if they have no idea and can't give it away, then the participant isn't able to guess who got what. And so they won't answer accordingly. And the placebo effect, again, adding a comparison group usually helps, sometimes even a third group, as we'll see in the graphs. So looking at the threats to internal validity, this is where I ask you the question, what are maturation threats? And again, we see that people's scores get lower, maybe just because they get more used to their surroundings or they mature in some way, some sort of spontaneous way. People get bored or tired, so they may have less interest in something at the end than they did in the beginning. In this case, for the example of maturation and rambunctious behavior, did the students or campers actually get less rambunctious because of the sugar, or was it simply maturation? If we add a group that did not get the low sugar treatment, we can see if both groups decreased about the same amount, or if there really was a difference. For this graph, this is the depression one, pre-therapy and post-therapy. So we have the no therapy group that didn't get any therapy, and we have the group that received therapy. What we see is there was a slight decrease from maybe 19 to 17 in the no therapy group, but from the therapy group, from 18 all the way down to like 11, what this shows is, okay, looks like the therapy group did decrease significantly more. So how is this maturation threat prevented? Add a control group that received no therapy, or maybe just talking to somebody as opposed to no treatment at all. For history threats, here we see kilowatt hours of power used between September and November. Now we see the history threat, again, is some sort of external event or things like that. For the campers, it could have been really hot, making them not want to be so crazy and rambunctious because they were just so hot. Or it could have been maybe the low sugar diet. In this case, we have the Go Green campaign that started in October. So you're looking at their usage from September through November. And no campaign at all. And what you see from this chart on the left in A is there's no difference. They're right on top of each other. So in that case, I would say there is a history threat here, because whether you went green, or whether they got the Go Green, or whether they didn't, they still decreased their kilowatt hours of power used about exactly the same. So it looks like the Go Green didn't really have any effect over the change, and the weather change was more likely. If we were to look at this one in B on the right, maybe we can see a difference here, right? The Go Green campaign decreased even more than the regular one. Maybe not by a lot, but you can see a difference. And the fact that you can see a difference means that that Go Green campaign was most likely at least marginally effective. So again, how are history threats prevented? Just like last time with maturation, we add a comparison group to make sure that it's not just some external event, or that the participants spontaneously matured in some way. For regression threats, regression to the mean could be extremely high scores beforehand. So a regression threat would be that scores were related, or scores went down simply because they scored closer to their average. So here, if we look at the top one on A, we could see for regression, I would say that this is not necessarily regression to the mean. So from the pre-test to the post-test in green, the no therapy group, they did decrease a little bit from 19 to say 17, but the group that got therapy was also at 19 and went all the way down to like 12. So I would say that you wouldn't really call it a regression threat that much. But what about the second one? The second one shows with the no therapy group, there was definitely no change. And even though the therapy group only went down a couple, we know it wasn't a regression threat, because the group that didn't receive therapy didn't change at all. They stayed at 15 from the pre-test to the post-therapy test. What about the last one? Well, here in the last one, again, saying the no therapy group, again, changed or didn't change, or only changed very slightly. And we have what we call a crossover, right? So in this case, we'd call that an interaction. The therapy group decreased in post-therapy, and again, the no therapy group didn't really change much. So either in any of these ones, I don't really see, maybe a little bit in the first one, but even then I wouldn't say that this was due to regression of the mean. And again, how did we do this? We added a control group that received no therapy just to see if they spontaneously got better, because they were simply very extreme. So how does regression affect internal validity? Again, it's a confound, because we don't know if therapy actually helped, or if they were so depressed before that they just naturally went down to their average, right? How can regression threats be prevented? as we've been talking about, as is the theme of this chapter, simply adding a comparison or control group. Attrition threats. The attrition threats are the fact that you may see a difference in scores from time 1 to time 2. We can talk about that. The top 2 scores here on A on the right give us a mean of 5.7. Those top 2 scores were the most extreme. Maybe they were the rambunctious campers and they got kicked out of the camp. And so they didn't make it back for the whole, they didn't make it back for the post-test at time 2 for the whole week because they were sent home after a couple days. And then the group was measured again for the post-test, and look, they went down from 5.7 to 4.3. The question is, did they go down simply because they got less rambunctious, or was it because the most 2 extreme scores were not there at the post-test? Because everything else looks exactly the same from time 1 to time 2. The only difference here in A is that the 2 most extreme scores were not counted at the post-test. So how do we prevent attrition threats? If they're not there at time 2, we eliminate their scores from the average at time 1. So the most rambunctious campers, their data gets eliminated and everybody else's stays the same. If we were to do that and remove those top 2 blue scores, then the means would be exactly the same, and you would say there seems to be no difference between time 1 and time 2. What about here? If we were to take out the 2 middle scores of the mean at time 1, right, 2 of the students or 2 of the campers that were sort of rambunctious but not, they just got really homesick and their parents came and picked them up. If we eliminated that at time 2, we would see almost the same mean, and this would tell us that this would show us what would happen there, right? So again, it would show us what the real average was. Attrition threats can be prevented that if they're not there for their scores at time 2 because they drop out of the study, you must eliminate their scores from the average of time 1. And that way you get a much more accurate projection. Testing threats. Again, testing threats would be exposure to the same tests more than once could cause their scores to go up. How do we mitigate this? We add a control group or comparison group. So here we're looking at an ability score on a math test or an anagram test or something like that. So at pre-test, they're fairly low, and at post-test, they're a lot higher. Could this be because they simply took the same version of the test and just remembered the answers, right? For a lot of people, that would be yes. But we can add a comparison group or a treatment group, right, to the treatment group. So here we have ones that saw the same test and maybe ones that saw a different post-test. We see that both of them increase pretty greatly from the beginning, from the pre-test to the post-test. So this might be harder to say that this was not a testing threat. If the comparison group didn't score much better, then we would probably say, okay, this treatment group was not due to the fact that they just saw the test, right? So again, instrumentation threats to internal validity. What's an instrumentation threat? That a coder gets more lenient, relaxes a little bit, doesn't concentrate as much, or equipment that you're using to measure is no longer calibrated and may need to be recalibrated. I think about playing a guitar, and the more you play it, the more the strings pluck, the more it tends to get out of tune. So if you're trying to, without ever tuning it, if you're trying to play 10 songs at a concert, right, by the 10th song, this is why people have guitar techs that bring them guitars and then tune them off stage while they're switching, then you might be playing in a completely different key by the 10th song if you don't adjust. So how can instrumentation threats be prevented? Make sure to recalibrate if needed. Make sure to check the instruments. Make sure that the person who is coding is just as lenient or just as strict from beginning to end. And then looking at instrumentation versus testing threats. Instrumentation has to do with the person measuring the outcomes. Testing threats has to do with the participants being exposed to the same things over and over again, right? So could we have combined threats? We talked about that. I talked about that a little bit. We could have a selection and history threat, some sort of outside event or or factor systematically affects participants at one level of an IV. Maybe you have one group take an exam that didn't study during the day, and where there's more distractions, it's hotter, people are talking in the hallways, and then the other group that did study, maybe they take theirs at night when there's significantly less people on campus. Well, obviously there's nobody on campus now, but that's neither here nor there. And some sort of outside event, or they do something during the summer, and other people do it during the winter. That may affect one of the levels of the IV. So that's selection and history. We can also have selection and attrition threats. Participants in one experimental group experience attrition. We could have a drug therapy, and some people could get reactions to the drug to try to help them with something. The other people have a different therapy. The people who take the drug therapy with side effects may be much more likely to drop out of a study afterwards than the people who have a non-invasive, non-drug type of therapy. And so you may systematically get one group that basically drops out a lot more than the other group, right? So that's a selection and attrition combined threat. And then, of course, the three potential internal validity threats in any experiment: observer getting the wrong thing, giving away what they want, leading somebody in a direction, or not, or being biased in the way they collect data, which could also be, again, a type of instrumentation threat. Demand characteristics, which is where the participant figures it out. In this case, to control for observer bias and demand characteristics, we use a double-blind study most of the time, or we mask the study. One of the coolest designs that I got from students when they did their experiments in my class was they wanted to look at low cognitive load and high cognitive load and things like that. And so they did a memory test. And so a masked study means that the participants don't actually know what's being studied. And I know that sounds manipulative, but it actually ends up working out pretty well, as long as you're not tricking people and messing with them, right? So in this case, for this example, they had people watch videos of, I think, Family Guy, and they were looking at remembering more things versus more specific things versus low cognitive load, which was just trying to think about, like, how many cookies were on the table or something like that, or how many characters were in the scene, something easier, right? And at the end, they did the memory task and they asked those questions. So the participants actually thought that was the test. They were trying to see how many they could get right. But afterwards, they had a bunch of snacks and stuff on the table, and it was the last experiment before they left for the day. So when you were done, you were able to get up and take some food or snacks and then go home. And so what they were really doing was counting how many snacks the people took, and they wanted to see if higher cognitive load, which takes more concentration, would make people more stressed or more hungry. And so they predicted that people in the high cognitive load would take more snacks than people in low cognitive load. I don't think they ever got a specific difference, but it was a really cool experiment, and nobody realized that the experimenters were counting how many snacks they took, right? So they were pretty shocked when they did the presentation of that study. And then, of course, placebo effects is, are they saying that they're feeling an improvement simply because something happened and not necessarily the actual treatment, right? So in placebo effects, we can design studies to rule out the placebo effect using a double-blind placebo control study. So looking at depression symptoms, using a true therapy, and then comparing it to a placebo therapy, which could just be having conversation with people and not really doing a cognitive behavioral type of trying to change the way they think and act, but just listening to them talk and get things off their chest. Here we see from the pretest to the post-test that the true therapy, they decreased a little bit more, but just talking to someone with placebo was almost as effective. So in this case, maybe it was just the fact that they had somebody to talk to. If we really want to see if the effects are due to a placebo, we could do a true therapy and a placebo therapy, and then add a third group, as I alluded to earlier, that gets no therapy whatsoever. So here we have, right, to see if we can parse out those effects. So on the on the right, we have true therapy in green, which again decreased the most. We have the placebo therapy, which all increased about halfway between. And then we have no therapy, where there was no implementation of anything at all. And you see that they decreased very slightly, maybe 1 or 2 points without therapy. But you can see that the placebo had about half of the impact of the true therapy in that case. So what are our dirty dozen and how do we control for them? Design confounds. Of course, we have control groups hold these things constant. Selection effects, we either randomly assign or we use the matching or match groups technique. Order effects, counterbalance. For maturation, we want to add a comparison group to make sure that it wasn't just due to the spontaneous maturation of the participants, that rambunctious boys will just tend to be less rambunctious at the end of their camp experience on day 5 or day 7. History, we want to add a control group, make sure that it's not some sort of outside event like the seasons changing that cause less energy and that it's actually due to the Go Green campaign. With regression to the mean, same idea. We want to make sure that we have people that have a comparison group to make sure they're not just lowering because it's closer to their actual average and that they were extreme on the pretest, or maybe add a second post-test to see if 2 and 3 are closer to their average more than 1. Attrition, we eliminate their data from the pretest if they're not there for the post-test. Testing effects, we want to make sure we don't use the same type of material or use an alternate version of a test. And instrumentation, make sure that things are rigorous, make sure that instruments are calibrated, and that the measurements are just as good from the beginning to the end. Once again, if you had a guitar and it's slightly getting out of tune every time you pluck the strings, you want to make sure that you have a guitar tech there to switch out your guitars as you go through every couple songs and retune them to make sure they're in the right key. Observer bias and demand characteristics. A lot of times we use a double-blind procedure using a research assistant that doesn't know what group people are in, and that way the participants don't get it, or use a mass design where the participants aren't, it's not obvious what they're doing for their experiments or for their tests. And with placebo effects, again, you can add a comparison group again, or even add a true control group and a comparison group to make sure that the effects are not just due to participants' expectations. So, with so many threats, the last thing we talk about is, are experiments really still useful? Well, if you control for those extraneous variables and confounds, the answer is yes, of course. For the pasta one, if all the pasta is exactly the same, and the only difference in your experiment is whether or not the bowl is medium or large, you've done a really good job to mitigate that threat. If you randomly assigned or used match groups to equalize the groups, you did a really good job to eliminate that threat. For order effects, if you counterbalance, you've eliminated that effect. So, yes, definitely still useful. For maturation, history, and regression, did you add a comparison group that didn't receive the same treatment to see if you can parse out the effects with and without treatment? Then you have mitigated, for the most part, that internal validity threat. 7 through 9, for attrition, don't add their scores for the pretest if they're not there for the post-test. So remove their scores. Testing and instrumentation, for testing, comparison group, make sure the tests were not the same. So that might be that manipulation check that we talked about also in chapter 10. Did the researchers train coders to use the same standards? Are the pre-test and post-test measures equivalent? Did we calibrate for any instruments that we may be using over and over again, especially if they're electronic? And if the answer is yes, then you've done a pretty good job of eliminating that potential internal validity threat, even before the experiment is over. Observer bias and demand characteristics. Did we use a double-blind or masked study? Placebo effect, again, adding a comparison group. Looking at those things, if we do a good job in our design, then a lot of times we have really good examples to go off of. And of course, experiments are still useful. Why would you be taking this class and learning about all this stuff if they weren't? When we come back for the next lecture, I will talk about how to interrogate null effects. Did you actually get no difference between groups, or was there some between or within group variance that was part of the problem? So after this quick break, I will be back. And so as I sign off, I say, as I always do, I will talk to you soon.